Myself Rana, a physics educator. I am teaching physics from last 7 to 8 years. Today I am going to show you my demo lecture through a simple topic, total internal reflection. So let's start total internal reflection. Before going to total internal reflection, first thing we should know about that, what do you mean understand from reflection and refraction? Reflection is that when a light passes from one medium and it will be get reflected from any surface in the same medium, then it is known as a reflection. And when we are going to discuss about refraction, in this case we are considering two medium. One is medium 1 and another is medium 2. And when light goes from one medium to another medium, like this is normal, in this case also this one is normal. And when a light goes from like rarer medium, medium 1 is rarer, mu 1 is lesser than mu 2. When it is passing from rare medium to denser medium, it will be bent towards the normal. These are the basics of optics. Okay. So in this phenomena, refraction, there is a condition which occur in optics is known as total internal reflection. In this phenomena, the light goes from denser medium to rarer medium. The first point in this topic we should consider is the light passes from denser medium to rarer medium. Okay. So, child, in this topic, we are going to discuss about internal reflection. So, first of all, I am going to show you through diagram how total internal reflection occurs, and after that, I will explain it theoretically. So, the first thing is that we are going to take a interface which divide the two medium. This one is your mu1 and this one is your mu2. You can also take mu2 and mu1. It depends upon you. So I think in NCRT it is provided that mu1 and mu2. That's why you can apply this one. Now, when a light goes from denser medium to rare medium, so we are considering from this point the light is going from denser to rarer medium. So when we are going to discuss about a small light particle, it will be go from denser medium to rarer medium. Here, this one is your medium 1 and this one is your medium 2. And medium 2, mu 2 is larger than mu 1. So this one is your denser medium and this one is your rarer medium. Now, when light passes from denser medium to rare medium, in the case of normal, when we are considering this one, consider it is not looking like a normal, but consider this one is your normal light. Okay, it passes from one medium to another medium without undeviated. After that, when light goes from denser to rarer medium, it will be go away from the surface. So when we consider this one is I, this gives the value of R. Now on further increasing the angle of incidence with normal, this one is N, so we can consider this as a N2. So the angle of refraction is also changes. So when light passes from denser medium to rarer medium, in this case also a situation is reached that the angle of incidence, this one is I dash, the refracted angle will become parallel to the interface at 90 angle. And at that angle where the angle of incidence gives the refraction value 90 degree with the normal, that angle is known as critical angle. This small angle is nothing but critical angle. And after proceeding from critical angle to some more angle where we are going to increase, then its value again increases from this, and after that the total internal reflection will be takes place simply. And in this case, the light will be totally reflected in their own surface in the same side. This one is your I double dash and this one is your R. So in this case, the light which passes from denser medium to rarer medium, the light will be not going from medium 2 to medium 1 and it will be internally reflected. This phenomena is known as total internal reflection. Now I am going to show you what is critical angle. So theoretically, so this one is your critical angle. In this case, the angle of incidence in denser medium when increases and at a specific angle or certain angle, the refracted ray makes 90 degree with normal or become parallel to interface is called critical angle. I think now you can understand the concept of critical angle. This is as angle at which the refracted ray will become 90 degree with normal. Okay. And after that, when we increase the angle, the phenomena of total internal reflection will be takes place. Now I'm going to describe what is total internal reflection. So in this case, light traveling from denser to rarer medium and when angle of incidence is increased above the critical angle, it will be totally internally reflected back to the denser medium. And this phenomena is known as TIR. total internal reflex. Now I am going to discuss about some mathematical term regarding the total internal reflection. So we know about the Snell's law. I'm just going to express the Snell's law and relating with total internal reflection. So we know about that mu1 sin I is nothing mu2 sin R. Okay, this is the value mu1 sin I is mu2 sin R. So simply this one is basic Snell's law. But in this question, TIR, we are going to discuss the light will be going from denser to rarer medium. So we can simply write sin I by sin R is 2 mu 1. And we can also write 1 upon 1 mu 2. Now, in this case, we know about that the angle I is critical angle. So we can denote it by IC. And the refracted angle is nothing but angle R is 90 degrees. So when we are going to put the value of both of them, this one is sine angle of critical angle divided by sine 90 degree is nothing but 1 divided by 1 mu 2, or we can simply write it 1 mu 2 divided by 1 by sine theta. So we got that mu is nothing but 1 by sine theta. So, and there is a small thing we know about that every material has its own critical angle. So some material has their own critical angle, such as like water has 48.75 degree. Simply diamond has 24.41 degree. It is. Thank you. See you soon, student, in my class.